code mandates that an equipotential common bonding grid extend under paved walking surfaces for 3 feet horizontally beyond the inside walls of a pool. In the Northeast region, a common practice involves installing the paved walking surface 1 year after the pool installation date. Faced with this situation, an inspector must make a judgment call, balancing code requirements and specific circumstances. One potential option is that if the inspector determines the pool's safety is not compromised without the paved walking surface, they could close the permit. However, this decision should be accompanied by a report noting the mandatory installation of the paved walking surface within 1 year, subjecting the permit to re-inspection upon completion. Alternatively, the inspector might deem the pool unsafe for use until the paved walking surface is installed. In this case, the contractor would be required to complete the paving before the permit can be closed, ensuring full code compliance before the pool is used. To proactively address potential delays or disagreements, installers should proactively coordinate with inspectors and local authorities. This collaboration aims to establish a clear, mutual understanding of the inspection process and the timeline for completing the pool installation project. It's crucial to remember that local codes and regulations can vary. Therefore, consulting with the appropriate authorities for specific guidance is essential. The equipotential bonding grid serves a critical safety function around swimming pools. Its primary purpose is to minimize voltage gradients in the area surrounding the pool. Voltage gradients occur when stray electrical currents flow through the ground, creating a difference in electrical potential between 2 points. These voltage differences can pose a shock hazard to individuals in or around the pool. The equipotential bonding grid works by creating a common electrical potential throughout the designated area, reducing the risk of dangerous voltage differences. By connecting various metallic components such as the pool's reinforcing seal, metal fittings, pumps, and other electrical equipment, the grid ensures that these components are at the same electrical potential. In the event of an electrical fault, the bonding grid provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker and quickly de-energizing the circuit. This rapid response minimizes the duration and severity of potential shocks. The 3-foot horizontal extension requirement for the bonding grid under paved surfaces is intended to address the risk of voltage gradients in areas where people are likely to be walking or standing near the pool. Paved surfaces can increase the conductivity of the ground, making it easier for stray currents to flow. By extending the bonding grid under these surfaces, the risk of voltage gradients is further reduced. When inspecting a pool installation, it is important to carefully verify that the equipotential bonding grid has been properly installed and connected. This includes checking the connections to all metallic components, ensuring that the grid extends the required distance under paved surfaces, and verifying that the grounding electrode system is properly connected. Inspectors should also be familiar with the relevant codes and standards, such as the National Electrical Code, which provide detailed requirements for pool bonding and grounding. Failure to properly install or inspect the equipotential bonding grid can create a serious safety hazard. Stray electrical currents can cause shocks, burns, and even death. By understanding the purpose and requirements of the bonding grid, inspectors can help ensure that swimming pools are safe for everyone to enjoy. Furthermore, proper documentation and communication are key to a smooth inspection process. Clear communication between the installer, the inspector, and the homeowner can prevent misunderstandings and ensure that all requirements are met. Detailed documentation of the bonding grid installation, including photographs and diagrams, can also be helpful for future reference. The inspector's judgment call, as discussed, is a critical point. Firstly, the inspector must assess the overall safety of the pool area without the final paving. Secondly, this assessment should consider factors such as the type of temporary surface present, the accessibility of the pool equipment, and the presence of any other potential hazards. Thirdly, if the inspector has any concerns about the safety of the pool area, they should require the contractor to take corrective action before closing the permit. The coordination between installers and inspectors should be proactive. Installers should reach out to the local inspection authority early in the project to discuss the specific requirements for pool bonding and grounding. This proactive communication can help identify potential issues before they arise and prevent costly delays. Installers should also be prepared to provide detailed documentation of the bonding grid installation to the inspector. This documentation should include a diagram of the grid, showing the location of all connections, as well as photographs of the connections. Proper pool bonding is not just a code requirement, it is a matter of safety. By taking the time to properly install and inspect the bonding grid, we can help prevent electrical shocks and ensure that swimming pools are safe for everyone. It is also important to remember that the requirements for pool bonding can vary depending on the local codes and regulations. Installers and inspectors should always consult with the local inspection authority to ensure that they are following the correct requirements. Staying up to date on the latest code changes is also essential. The National Electrical Code is updated every 3 years, and these updates can include changes to the requirements for pool bonding. By staying informed about these changes, installers and inspectors can ensure that they are always using the most current and effective methods for pool bonding. In addition to the equipotential bonding grid, there are other safety measures that should be taken to protect against electrical hazards around swimming pools. Ground fault circuit interrupters, or GFCIs, are required for all electrical circuits that serve pool equipment. GFCIs are designed to detect small amounts of current leakage and quickly shut off the power to the circuit, preventing electrical shocks. All electrical equipment around the pool should be properly grounded. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and energizing the circuit. Overhead power lines should be kept a safe distance from the pool. The National Electrical Code specifies minimum clearances for overhead power lines near swimming pools. It is important to follow these clearances to prevent accidental contact with power lines. Swimming pools can be a great source of enjoyment, but it is important to remember that they can also be dangerous if not properly installed and maintained. By following the safety measures outlined above, we can help ensure that swimming pools are safe for everyone to enjoy. Regarding the inspector's decision on whether to close the permit before the paved walking surface is installed, there are several factors to consider. Firstly, the local interpretation of the code plays a significant role. Some jurisdictions may have stricter interpretations than others, and inspectors are obligated to enforce the code as it is interpreted in their area. Secondly, the inspector will assess the potential risks associated with the absence of the paved surface. This includes considering the type of temporary surface, the accessibility of the pool equipment, and the presence of any other potential hazards. Thirdly, the inspector will likely consider the contractor's plan for completing the paving. A detailed plan with a firm timeline can provide assurance that the paving will be completed in a timely manner. If the inspector decides to close the permit before the paving is installed, they should clearly document the conditions of the closure. This documentation should include a statement that the paving must be installed within 1 year and that the permit will be subject to re-inspection at that time. The inspector should also provide the homeowner with a copy of this documentation. Communication is key to a successful pool installation project. Installers, inspectors, and homeowners should all communicate openly and honestly to ensure that everyone is on the same page. This communication should begin early in the project and continue throughout the process. By working together, we can ensure that swimming pools are installed safely and in compliance with all applicable codes and regulations. The equipotential bonding grid is a critical component of pool safety. It is designed to prevent electrical shocks by creating a common electrical potential throughout the pool area. The grid is typically made of copper wire and is connected to all of the metallic components of the pool, including the pool's reinforcing steel, metal fittings, pumps, and other electrical equipment. The grid is also connected to the grounding electrode system. The grounding electrode system provides a path for fault current to flow back to the source, tripping the circuit breaker and energizing the circuit. The National Electrical Code specifies detailed requirements for the installation of equipotential bonding grids. These requirements include the size and type of wire to use, the spacing of the grid, and the methods for connecting the grid to the metallic components of the pool and the grounding electrode system. It is important to follow these requirements carefully to ensure that the bonding grid is properly installed and will provide effective protection against electrical shocks. In addition to the equipotential bonding grid, there are other safety measures that should be taken to protect against electrical hazards around swimming pools. Ground fault circuit interrupters, or GFCIs, are required for all electrical circuits that serve pool equipment. GFCIs are designed to detect small amounts of current leakage and quickly shut off the power to the circuit, preventing electrical shocks. All electrical equipment around the pool should be properly grounded. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and de-energizing the circuit. Overhead power lines should be kept a safe distance from the pool. The National Electrical Code specifies minimum clearances for overhead power lines near swimming pools. It is important to follow these clearances to prevent accidental contact with power lines. Swimming pools can be a great source of enjoyment, but it is important to remember that they can also be dangerous if not properly installed and maintained. By following the safety measures outlined above, we can help ensure that swimming pools are safe for everyone to enjoy. When considering the timing of the paved walking surface installation, it's beneficial to understand the reasons behind the common practice of delaying this installation. One reason is to allow for soil settlement around the newly installed pool. The backfilling process can sometimes lead to uneven settling, and installing the paving immediately might result in cracks or other damage as the ground compacts. Delaying the paving allows for this natural settling to occur, ensuring a more stable base for the paved surface. Another reason for delaying the paving is to allow the homeowner time to finalize their landscaping plans. The pool area is often integrated into a larger landscaping design, and homeowners may want to wait until they have a clear vision for the overall landscape before installing the paved walking surface. This allows them to choose paving materials and designs that complement the surrounding landscape. From an inspector's perspective, it's crucial to balance the code requirements for the equipotential bonding grid with the practical considerations of the paving installation timeline. As mentioned, communication with the installer and homeowner is key. Understanding the reasons for the delay and the plans for completing the paving can help the inspector make an informed decision about closing the permit. If the inspector chooses to close the permit before the paving is installed, it's essential to clearly document the conditions of the closure, including the deadline for completing the paving and the consequences of failing to meet that deadline. This documentation should be provided to both the installer and the homeowner. The reinspection process is also important. When the inspector returns to verify the completion of the paving, they should carefully inspect the bonding grid to ensure that it is properly installed and connected under the paved surface. They should also verify that the paving has been installed in accordance with all applicable codes and regulations. The NEC, or National Electrical Code, provides comprehensive guidelines for electrical installations, including those related to swimming pools. The code is updated every 3 years, and it's important for installers and inspectors to stay up to date on the latest changes. The NEC addresses various aspects of pool electrical safety, including bonding, grounding, wiring methods, and equipment installation. Specific sections of the code address the requirements for equipotential bonding grids, including the size and type of wire to use, the spacing of the grid, and the methods for connecting the grid to the metallic components of the pool and the grounding electrode system. The NEC also includes requirements for ground fault circuit interrupters, or GFCIs, which are designed to protect against electrical shocks. GFCIs are required for all electrical circuits that serve pool equipment. In addition to the NEC, local codes and regulations may also apply to pool installations. It's important for installers and inspectors to be familiar with these local requirements to ensure that all installations are in compliance. The overarching goal of these codes and regulations is to ensure the safety of individuals using and around swimming pools. Electrical hazards can pose a serious risk, and it's crucial to take all necessary precautions to prevent accidents. Proper bonding, grounding, and the use of GFCIs are essential components of pool electrical safety. Regular inspections and maintenance can also help to identify and address potential hazards before they become a problem. By following these guidelines, we can help ensure that swimming pools are safe and enjoyable for everyone. The potential consequences of improper bonding around a swimming pool are severe, ranging from minor shocks to fatal electrocution. Stray electrical currents in the ground or pool water can create dangerous voltage gradients, putting swimmers and anyone near the pool at risk. Proper bonding minimizes these voltage gradients, reducing the likelihood of electrical shock. Firstly, the equipotential bonding grid connects all metallic components of the pool system, ensuring they are at the same electrical potential. Secondly, this includes the pool's reinforcing steel, metal fittings, pumps, filters, heaters, and any other electrical equipment. Thirdly, in the event of an electrical fault, the bonding grid provides a low impedance path for the fault current to flow back to the source, tripping the circuit breaker and quickly de-energizing the circuit. Fourthly, this rapid response minimizes the duration and severity of potential shocks. Fifthly, without proper bonding, even small amounts of stray current can create dangerous voltage differences, leading to painful or even deadly shocks. Sixthly, children, in particular, are more vulnerable to electrical shock due to their smaller size and lower body resistance. Seventhly, for this reason, it is essential to ensure that all pool installations meet the highest safety standards. Eighthly, regular inspections and maintenance can help to identify and address any potential bonding issues before they become a hazard. Ninthly, homeowners should be educated about the importance of pool bonding and the signs of potential electrical problems. Tenthly, if they notice any unusual sensations while in or around the pool, such as tingling or shocks, they should immediately turn off the power to the pool and contact a qualified electrician. 11thly, the consequences of improper bonding are simply too great to ignore, and it is crucial to prioritize safety in all pool installations. The inspector's role in ensuring pool safety is paramount. They are the last line of defense in preventing electrical hazards and ensuring that pools are installed in accordance with all applicable codes and regulations. Firstly, the inspector must have a thorough understanding of the NEC and all local codes and regulations related to pool electrical safety. Secondly, they must be able to identify potential hazards and assess the effectiveness of the bonding and grounding systems. Thirdly, the inspector should carefully examine the equipotential bonding grid to ensure that it is properly installed and connected. Fourthly, this includes verifying the size and type of wire used, the spacing of the grid, and the methods for connecting the grid to the metallic components of the pool and the grounding electrode system. Fifthly, the inspector should also verify that all electrical equipment is properly grounded and that GFCIs are installed on all circuits serving pool equipment. Sixthly, in addition to the physical inspection, the inspector should also review the documentation for the pool installation. Seventhly, this includes the electrical plans, the bonding grid diagram, and the test reports for the grounding electrode system. Eighthly, the inspector should also communicate with the installer and the homeowner to address any questions or concerns. Ninthly, if the inspector identifies any deficiencies, they should clearly document them and require the contractor to take corrective action. Tenthly, the inspector should not close the permit until all deficiencies have been corrected and the pool meets all applicable codes and regulations. 11thly, the inspector's diligence and attention to detail are essential for ensuring the safety of swimming pools and preventing electrical accidents. The recommendation to coordinate with inspectors and local authorities highlights the importance of collaboration in ensuring pool safety. Firstly, installers should proactively reach out to the local inspection authority early in the project to discuss the specific requirements for pool bonding and grounding. Secondly, this proactive communication can help identify potential issues before they arise and prevent costly delays. Thirdly, installers should be prepared to provide detailed documentation of the bonding grid installation to the inspector. Fourthly, this documentation should include a diagram of the grid, showing the location of all connections, as well as photographs of the connections. Fifthly, installers should also be willing to work with the inspector to address any concerns or deficiencies that may be identified. Sixthly, local authorities, such as the building department or the electrical inspector's office, can also provide valuable guidance and support. Seventhly, they can help to clarify code requirements, provide interpretations of the code, and offer advice on best practices for pool installations. Eighthly, by working together, installers, inspectors, and local authorities can ensure that swimming pools are installed safely and in compliance with all applicable codes and regulations. Ninthly, this collaboration can also help to build trust and understanding between the different parties involved in the pool installation process. Tenthly, ultimately, the goal is to create a safe and enjoyable swimming pool environment for everyone. 11thly, open communication and collaboration are essential for achieving this goal.